This lesson, we're going to be talking about the difference of squares. This is when you have two things that you can take the square root of. So like you can take the square root of a squared and come up with a. You can get the square root of b squared and come up with b. And the big key word here is it has to have that subtraction sign. Otherwise, it is not a difference. So if you do not have the subtraction sign, you cannot do this method. So let's take a look at let's do a couple of examples. Or actually, before we get to the examples, let's take a look at what are the perfect squares. And so if you want to write it down as we go through it, you have 1 squared is 1, 2 squared is 4, 3 squared is 9, and so forth. And anytime you factor it, you always take the square root of the first term, and you find the square root of the second term. So we have a and b, like we talked about before. We're going to put them in the parentheses. And the first one's going to have a plus sign in between it, and the second one's going to have a minus sign in between it. And it's that simple. So let's do a couple of examples. Let's look at this first one. So, first question you always ask, can I take the square root of m squared? And that answer is yes, it's m. Can I take the square root of 25? The answer is yes, it's 5. So my factoring, put my two parentheses, I do m and 5, m and 5. One of the parentheses has a plus, one parenthesis has a minus, and you are done. It can get more complicated if you start adding in some GCFs, or sometimes you'll have to factor further. But for these first couple, there is no GCF here, so I take and look and see, can I take the square root of 9x squared? And the answer is that's 3x. Can I take the square root of 49y squared? And the answer is yes, it's 7y. So I have 3x and 7y, 3x and 7y. One parenthesis is going to have a plus, the other parenthesis is going to have a minus, and then we are done. And so the next one we're going to look at, number 7, we notice that there is a GCF this time. So there is a common factor that I can factor out. And so I need to look for what is my GCF. What number can divide into both 5 and 80? And the answer is 5. And so we're going to factor out that 5, and it's going to leave us with r squared minus 16s squared. And I want to take what's in the parentheses, and I want to see, can I take the square root of each of them? And so I get a 4s and a r. So my GCF just hangs out in the front. I don't do anything with it. I leave it alone. And then I take my two square rooted answers, put them in the parentheses, and I put one with a plus and one with a minus. And I am done. Let's look at number 8. So again, I look for that GCF. What is my GCF of the two of these? Well, my GCF is 2. So I can factor out a 2. And that leaves me with 36 c to the 4th minus 1. Now I check. I have that minus sign so I can check the next step. 36 c to the 4th. If I take the square root of it, gives me 6c squared. If I take the square root of 1, it gives me 1. So I create my two parentheses, one with a 6c squared minus 1, and one with a 6c squared plus 1. And write my GCF in the front, and then I'm done. Looking at 9. This time I have multiple variables. I'm still going to look for that GCF to begin with. And so as my GCF, we look and see, okay, what number can divide into 7 and 28? And the answer is 7. What's my least amount of m's? And that would be m. What's my least amount of n's? And that's n. So I have 7mn that I'm factoring out. And so that leaves me with m to the 6th minus 4n squared. I'm going to take the square root of both of those. M to the 6th gives me, when you're doing the square root of a power, it really is just taking half of that power. So that's going to be m cubed. So we're thinking about what number times itself will give us m to the 6th. Take the square root of 4n squared, and I get 2n. So my two parentheses are m cubed plus 2m, m cubed minus 2m. And so my GCF is 7mn, and that's my answer. Our last, or number 10, we have to find the GCF of these. And my GCF is going to be 10w. So if I was to factor that out, I would write 10w, and I have what's left is going to be 10w to the 4th, or excuse me, 1w to the 4th minus 1. Because remember, negative 10w divided by 10w gives me that negative 1. So now I'm going to do that next step, which was take the square root of both of those items. Square root of w to the 4th is w squared. Square root of 1 is 1. And so I write down my GCF, which is 10w. Next thing I write down is w squared plus 1. And then I look and see w squared minus 1. And so since there's still a power on these, I have to look and check. Since there's a plus here, that means I'm done. That one can't go any further. This one I need to check. And so if I take the square root of w squared, it comes up with w. Can I take the square root of 1? It comes up with 1. And so that gives me w plus 1, w minus 1. And then I'm going to write down everything else that we had originally back in the problem. W squared plus 1, because there's that addition here. That means I couldn't factor it any further. And then my GCF was 10w.